3.5 goes over graphing linear equations in slope-intercept form. The first part of this lesson goes over slope and finding slope from ordered pairs and graphs. When you look at these graphs, your textbook does it a little bit differently than I do. I look at these graphs from left to right. Once I see my graph from left to right, I can tell whether or not it's going to be a positive slope or a negative slope because I look at the way the line runs. As long as I'm looking at this from left to right, if my line's going up, then it's a positive slope. My fraction is going to be positive. From left to right, if it's going down, my slope's going to be negative. That's only if you look at it from left to right, though. You can't look at it like any other way. Look at it like you're reading a book, okay? I go up before I go to the right. If I'm going to the right, my bottom number in my fraction is always going to be positive. If I go down first, then my slope's going to be negative. If I go up first, my slope's going to be positive. So if I look at example 1, I'm just finding the slope of each of these lines. For A, we have 2 points on here, and I don't even bother with those 2 points. I look at where those ordered pairs are. My one to the left is that bottom left one that I'm going to start with. From there, in order to get to my next ordered pair to the right of this, I'm going to go up and to the right. Now I go up 4 places, and I go to the right 6. So whatever I go up is going to be my numerator. Whatever I go to the right is going to be my denominator. I then simplify this. The 4 over 6 simplifies by dividing each of these numbers by 2, and we're just going to have 2/3. So my slope is just 2 over 3. For example B, I look at this slope from left, or I look at this line from left to right, my line's going down. So I know that my slope's going to be negative. I start with my first point. From there, I'm going down 3 places, and then to the right 2. So if I'm going down 3 and to the right 2, this is going to be a negative 3 over 2. So my slope is just negative 3 over 2. For example C, I look at this line from left to right. My line's going down or moving downward, so I know my slope's going to be negative. I start with that first point that's to the left and up. I'm going to be going down 2 and then to the right. Now I go to the right 1, 2, 3, 4, 5 places. So my slope is going down 2 over to the right 5. If I'm going down 2, that's going to be a negative 2 over 5. For D, I look at this line from left to right. My line's going up. So I'm going to first go up. I go up 4 places, and then I go to the right 6. So my slope is going to be a positive 4 over 6, which simplifies to just be 2/3. For E, we look at this line from left to right. That line is going up. So again, my slope's going to be positive. I start at that 2, negative 3, and I go up. Now, when I go up, I'm not going a full 4 places. I'm going 3.5 places up. And then I go to the right 1.5. So this is going to give me a slope of 3 1/2 over 1 1/2. If you wanted to write this as decimals, you could. I'm going to redo it once I'm done with decimal form, so you see it both ways. With this, you're just going to turn the 3 1/2 into a mixed number. That gives us 7 over 2. And fractions represent division. So that's 7 over 2 divided by 1 1/2, which is 3 over 2. So from here, we're just dividing this 7 over 2 divided by 3 over 2 once I turned that 3 1/2 and the 1 1/2 into an improper fraction. So I'm going to keep change flip. This is going to be 7 over 2 times 2 over 3. Those 2's cancel out to be 1, so I'm just doing 7 over 1 times 1 over 3, which is 7 over 3. So my slope is just 7 over 3. If I chose to use decimals, which isn't a problem, typically with linear functions we don't use decimals, we use fractions, I would just have 3.5 over 1.5. I can't have decimals in fractions, so I turn it into a 35 over 15. You have a common factor of 5 with both of those, so we divide them by 5, and that gives me 7 over 3. So again, you're getting the same answer, just a different way of looking at it or doing it. It's not wrong if you use the decimals, but like I said, typically with linear functions, we use fractions because slope is represented as a fraction. With your next part of your lesson, we're dealing with the actual formula to find slope. So the formula to find slope is your slope, or m, is equal to y2 minus y1 over x2 minus x1. In order to find the slope of a line, you only need 2 ordered pairs from that line. So 2 points from that line. One will be the ordered pair labeled 1, one will be the ordered pair labeled 2. With the next set of examples, you're going to be given tables with x values and y values that represent ordered pairs on a coordinate plane. For example 2a, we have x values of 4, 7, 10, 13, and y values of 20, 14, 8, 2. You can pick any of these points. This is just for 20, the point 7, 14, the point 10, 8, and the point 13, 2. So you could literally pick any of these ordered pairs from this table and use 2 of them in order to find your slope. For this example, I'm going to use the first 2 points. I'm going to say that this 420 is going to be my first point, and then this 714 is going to be my second point. So when I do this, I identify my x1 as 4. My y1 has to come from that ordered pair, so that would be 20. My x2 is 7, so my y2 has to come from the same ordered pair that the 7 came from for my x2. So that's 14. To find my slope, I'm going to use my formula. So I'm going to have m is equal to y2 minus y1 over x2 minus x1. I plug these values in. So I'm going to have 14 minus 20 over 7 minus 4. The 14 minus 20 gives me negative 6. The 7 minus 4 gives me 3. So I just simplify this, and I get that my slope is negative 2. If we look at example B, we have the ordered pairs negative 1, 2, 1, 2, 3, 2, and 5, 2. In this case, I'm just going to pick randomly. I'm going to use the second and the last point. So the 1, 2, and the 5, 2. So I'm going to use the 1, 2 as my second point and my 5, 2 as my first point. So the x value is going to be, x1 is going to be 5, meaning my y1 is going to be 2. My x2 is going to be 1. My y2 is going to be 2. So we have m is equal to y2 minus y1 over x2 minus x1. So I'm going to plug these in. M is equal to y2, which is 2, minus y1, which is 2, all over x2, which is 1, minus x1, which is 5. So 2 minus 2 gives us 0. 1 minus 5 gives us negative 4. I have 0 in the numerator of my fraction, so automatically my slope is 0. So whenever 0 is in the numerator of the fraction, we have 0 as our slope. For example C, we have the ordered pairs -3, -3, -3, 0, -3, 6, -3, 9. So I'm going to choose the two middle. My -3, 0 is going to be 0.1. My -3, 6 is going to be 0.2. So my x1 is -3. My y1 is 0. My x2 is -3. My y2 is 6. So again, my slope formula, y2 minus y1 over x2 minus x1. So from here, I'm just going to plug my values in. I have 6 minus 0 all over -3 minus -3. The two negatives next to each other turn into positives. So I'm going to do 6 minus 0, which is 6, and -3 plus 3, which is 0. You cannot have 0 in the bottom of the fraction. 0 cannot be in the denominator. So whenever this happens, our slope is undefined. For example D, we have the ordered pairs 210, 415, 620, and 825. So I'm just going to use my first two. The 210 is going to be 0.1, the 415 is going to be 0.2. So my x1 is 2, my y1 is 10. My x2 is 4, my y2 is 15. So my slope formula, I have y2 minus y1 over x2 minus x1. So I'm going to have m is equal to 15 minus 10 over 4 minus 2. From here, the 15 minus 10 is going to give me 5. The 4 minus 2 is 2. So my slope is just the 5 over 2. For E, we have the ordered pairs 5, -2, 5, -12, 5, -9, 5, -6, and 5, -3. So I'm going to use the first and the last. So I'm going to do x1 is 5, y1 is -12, x2 is 5, y2 is -3. So again, slope is equal to y2 minus y1 over x2 minus x1. So my slope is -3 minus -12 all over 5 minus 5. The two negatives turn into positives, so I get m is equal to -3 plus 12, which is 9, over 5 minus 5, which is 0. Once again, you have that 0 in the denominator, which you cannot have, so we have a slope that's undefined. So as an overview so far, looking at this little table, when we look at our line and we read it from left to right, and we see that that line's going up from left to right, that just means we have a positive slope. If we look at our line from left to right and that line's going down, we have a negative slope. Any horizontal line, so a line that's straight that goes right through the y-axis is a horizontal line, will have the slope of 0. Any line that has a slope of undefined is a vertical line that goes through the x-axis. When we are graphing these slope-intercept form equations, we are first going to be looking for the slope and the y-intercept from the equation. So with this, for example, 3, we're just pulling out the slope and the y-intercept. Our slope is the coefficient of x. So in this case, for example 3a, we have a slope of 3. And our y-intercept is that ordered pair, which is recognized as b, that is that constant within your equation. So in this case, it's at -4. So it's the point 0, -4. For B, we have y is equal to 6.5. So we do not have something times x here, so our slope would be 0. And then our y-intercept, or our B, is just the ordered pair 0, 6.5. For example, C, we have negative 5x minus y is equal to negative 2. We want to move those terms to the opposite side in order to get y by itself. So we add that 5x to both sides. We get negative y is equal to 5x minus 2. And then we divide each side by that negative 1. We switch the signs on everything up top. Get rid of that bottom. We have y is equal to negative 5x plus 2. So our slope is negative 5, and our y-intercept is the ordered pair 0, 2. For D, we have y is equal to negative 6x plus 1, so our slope is at negative 6, and our y-intercept is 0, 1. For E, we have y is equal to 8, so again, we don't have something times x, so our slope is 0, and our y-intercept is 0, 8. For F, we have x is equal to x plus 4y is equal to negative 10. So we're going to subtract that x from each side. We get 4y is equal to negative x plus minus 10. Then we just divide each side by that 4 and get y is equal to negative 1/4 x minus 5 over 2. So from this, our slope is the negative 1/4. Our y-intercept is 0, negative 5 over 2. For our last part of our notes, we're just graphing these linear equations and identifying the x-intercept. As long as they are in slope-intercept form, so y equals mx plus b, we can pull out our slope and our y-intercept, graph that y-intercept, and then use our slope to find the next point or points. For A, we have 2x plus y is equal to 2. So we're going to subtract that 2x from each side to get us to that y is equal to negative 2x plus 2. Our slope is negative 2, so we're going to go down 2 to the right 1. And our y-intercept is that 0, 2. So on our coordinate plane, we're going to plot a point at 0, 2. Then we're going to go down 2 to the right 1. You could use those 2 points, or you can completely go throughout your entire coordinate plane, giving yourself your points on both sides of that y-intercept, and draw your line through those points. So I have all of my points here that my line is going to go through. So I just draw my line through those points, carrying it through the entire coordinate plane with an arrow at the top and the bottom of that line. My y-intercept is that 0, 2. So my x-intercept for this is 1, 0. For example B, we have y is equal to 4x minus 4. So our slope is 4. Our y-intercept is negative 4, which is the ordered pair 0, negative 4. And our slope is up 4 to the right 1. So 0, negative 4, first point. Up 4 to the right 1. Up 4 to the right 1. And again, we can completely go through our entire coordinate plane. That way we have a straight line through, or a diagonal line that goes through the entire thing. Our y-intercept is that 0, negative 4. Our x-intercept is 1, 0. For C, we have 3x plus y is equal to negative 3. I'm going to move this 3x over by subtracting it from each side. I just have y is equal to negative 3x minus 3. So this gives me a slope of -3, so I'm going to go down 3 to the right 1. And then my y-intercept is the -3 also, so that's the ordered pair 0, -3. So at 0, -3, I plot my first point, and then I'm going to go down 3 into the right 1, down 3 to the right 1, or up 3 into the left 1. I have all of my ordered pairs here that go through this coordinate plane to give me my line. So I draw my line through my points, and then my y-intercept is that 0, -3, so my x-intercept is that -1, 0. For D, we have x plus 2y is equal to 6. I'm going to subtract this x from each side, so I get 2y is equal to -x plus 6. I then divide each side by that 2, so I get y is equal to -1/2 x plus 3. My slope is -1/2, so I'm going to go down 1 to the right 2 after I plot that y-intercept of 0, 3. 0, 3 is here. From there, we're going to go down 1 to the right 2. Or up 1 to the left 2. So I draw my line through those points. And then I need to identify my x-intercept, which is that 6, 0.